Hi, welcome to this video on tutorial of an LDR. Here I will be explaining you what is an LDR and actually how it works. Now LDR is an acronym for light dependent resistor. It is also known as a photoresistor. As the name suggests, we can see that it is a resistor that actually depends upon the intensity of light. Here the value of the resistor actually changes depending upon the incident light, that is the ambient light that is incident upon the resistor. Let us see actually what makes it photosensitive. Let us see the construction of an LDR. So this is an LDR and it has been labeled for whatever things are there. First of all, we have two electrodes that we use for mounting on our PCBs or the breadboards. This is the first electrode, this is the second electrode, and over the top we can see some spiral lines. As the name indicates, they are photoconductive material. Actually now this is a material that whenever it senses light, that means whenever some photons are incident over it, the electrons in the non-conductive band get excited to conductive band, and thus it actually reduces the resistance, overall resistance of the between the terminal electrode 1 and electrode 2. So if suppose the resistance between these two terminals were like 1K and now we have some more light incident upon it, that means some more photons and some more free electrons, excited electrons, and we have more freely moving electrons, that means more a lesser resistance, and due to which the light dependent resistor behaves as it is. And other things we have here, like the ceramic beads, actually ceramic plate that is used to support the LDR, and the cold weld contacts just for contact purpose. Now let us see an actual simulation of how an LDR works. Now this is the simulation of an LDR working. Here we have an LDR connected in a potential divider fashion, where we have this 1K resistor in series with the LDR, and the 1K resistor in turn is connected to the VCC. That means whenever the resistance of the LDR is increased or decreased, it will generate a variable voltage over this terminal. And similarly we have another terminal where a voltage is generated due to the pot and this 10K resistor. So we will call this as the reference voltage that we will give on the non-inverting terminal of the op-amp, and to the inverting terminal of the op-amp we will give our signal generated due to the LDR. And in turn we will connect the output of the op-amp to the LED, where the output of the op-amp will be dependent upon if the LDR voltage is higher or lower than our reference voltage. So let us start the simulation and see how it works. As we can see, the reference voltage is 2 volts and the LDR voltage, due to the intensity of the light, is something like 4.76 volt. Now due to this, as this is the non-inverting terminal, is 2 volt and the inverting terminal is 4.76 volts, so that is why the LED is off. Now if we want that the LED should be turned on, then our inverting terminal should be less than the non-inverting terminal. So now let us increase the intensity of light on the resistor so that the resistance of this becomes less and less and the potential will decrease over here. So as we increase, we can see that the voltage on the potential divider network is actually decreasing, and now it's at par, like 2.4 volts, and now it has reduced 1.6 volts. So as it is less than this, so that is why now we have the LED glowing. So the basic funda of an LDR is like it will just act as a potential divider whenever connected in this way, and depending upon the intensity of light, it will generate a potential across this terminal, which can be used by any op-amp or a microcontroller for giving an information relating to the ambient light conditions. So this was about the simulation of LDR working. Thank you.